Hi guys, and welcome to day 3. We're talking about properties of parallelograms today. Quite a few definitions along with some diagrams here, so be prepared to jot down quite a few words. So first of all, defining a parallelogram. This is a quadrilateral. We've talked about quadrilaterals in past lessons, but a type of quadrilateral where both opposite sides are parallel to each other. So we'll say with both opposite sides parallel to one another. So if you look at the diagram to the right, notice that we have two sets of opposite sides. AB and CD are parallel to one another, and then similarly BC and AD are parallel to one another. Now this leads us into a few different theorems, first of which is our opposite side parallelogram theorem, and this says if a quadrilateral is a parallelogram, then opposite sides are congruent. So we'll say if a quadrilateral, let's abbreviate it, is a parallelogram, so we have to establish that first, then the opposite sides are congruent. So we'll say then opposite sides are congruent. So not only are opposite sides parallel, but they're also congruent. So if I'm looking at my diagram to the right of this definition here, once again I have two sets of parallel sides. Side AB has a distance or a length of 4, just as side CD does. And then we have BC, which is 6, along with AD, which is 6. So opposite sides are congruent. This leads us into our opposite angles parallelogram theorem. And this says if a quadrilateral is a parallelogram, so it first has to be a parallelogram, then opposite angles are congruent. So if a quadrilateral is a parallelogram, then opposite angles are congruent. Opposite angles are congruent. So not only do we have this relationship of opposite sides being congruent, but also opposite angles. So angle B here and D are opposite one another. They both will have the same measure, just as angles A and C will be congruent to each other too. And that's just the nature of with those parallel lines intersecting, it kind of creates that arrangement. Next we have the consecutive angles parallelogram theorem. And this says, once again, if a quadrilateral is a parallelogram, then consecutive angles are supplementary. So not congruent is kind of a break from the pattern. So if a quadrilateral is a parallelogram, that was a mini L, then consecutive angles are supplementary. So again, deviation from the pattern. These are no longer congruent, but we're talking about angles that are consecutive, meaning they're next to each other. So angles P and S, for example, are consecutive because they're next to one another. 41 plus 139 is going to give us 180 degrees. Next, we have this concept of diagonals of a parallelogram theorem. And just for your reference, diagonals are the lines that connect the opposing vertices. And we say that if a quadrilateral is a parallelogram, diagonals bisect each other. So if a quadrilateral is a parallelogram, then diagonals bisect each other. And remember that when we talk about bisecting, that means it cuts it perfectly in half. So, for example, this diagonal would be cut perfectly in half by the other, and so that's going to create sets of congruent line segments, right? Because bisecting means it's cutting it perfectly in half. All right, so let's look at some examples here. So we are told that FGHJ is a parallelogram, and we want to find the unknown lengths. And we have a couple given to us. They're asking us to find JH, and we know JH is going to be congruent to FG because they are opposite, right? So we can say that JH is going to 5. FH is going to be the length of this full, oops, I meant to change the highlighter. Length of the full diagonal, this whole thing here. So if half of it is 3, right, this is given to me here, then I know it's bisected. This also has to be 3. So the full length is going to be 6. Okay, we can use our properties in the context of angles as well. So if they're asking us to find the measure of angle R, knowing that it's opposite angle P, and we know according to our opposite angles parallelogram theorem that these have to be congruent, right, if they're across from one another. So this has to be 70 degrees as well. Angle Q is consecutive to angle P, right? So these two are neighboring angles, and that means they're supplementary. So the measure of angle Q is going to be 180 degrees minus 70 degrees. We're taking out that other measure. And so that's going to leave us with 110 degrees for angle Q. Okay, so again, it comes down to being able to determine how do the angles or the sides relate to one another, and does that make them congruent, or in the case of angles, supplementary. Okay, next we're finding the values of x and y here, and we are introducing some algebra. So if we're looking for x, let's see what we can relate x to. So since it's in the vicinity of angles, it can be related to 120. And we know those are consecutive, so they have to be supplementary, meaning 3x plus 120 has to equal 180. So if I go and solve, subtract 120 from both sides to get 60, divide both sides by 3, so I get x equals 20. And then for y, I'm looking at, okay, y pertains to the side measures. And the two expressions that are given are representing sides that are opposite from one another. And we know that sides opposite have to be congruent. So 3y plus 10 equals y plus 26. And if I subtract a y from both sides, 2y plus 10 equals 26. Subtract 10 from both sides, 2y would be 16. Divide both sides by 2, and y would be equal to 8. There we have it. Okay, next, because it's not a complete lesson without a word problem, we have some generic names here: Gracie, Kenny, Teresa, and Billy Bob, living at 4 corners of a block shaped like a parallelogram. And that's so convenient that it's a parallelogram, just engineered right into the neighborhood there. Gracie lives 3 miles from Kenny, so this is the distance that's given to us. And we want to see how far apart do Teresa and Billy Bob. Bless Billy Bob's heart. Can imagine having a name like that, huh? We know these sides are opposite one another, so they have to be congruent. So this would also be 3 miles here. And that's it, guys. Pretty straightforward. It's really just kind of getting familiar with all of these theorems. Thanks for watching.